Hello students, welcome to my class. In this video, we are going to be discussing about kinetic energy, relation between kinetic energy and momentum, potential energy related problems we are going to be discussing. Here in kinetic energy, let us see the first question. A body of mass 5 kg, it's given, initially it was at rest, is subjected to a force of 40 Newton it was given. Find the kinetic energy acquired by the body at the end of the 5 seconds they are asking. So here a body is given, that is 5 kg mass. Initially it was at rest, it is given. Now you are applying some external force. This is 40 Newtons. Now here let us calculate first with what acceleration the body is moving. A equals to, according to second law of motion, A equal to F by m you can write, which is nothing but here you will be taken as 40 by, here a mass is given as 5. So 5, 8 times it is, here A equals will be getting as 8 meter per second square you are writing. Now here let us calculate here velocity at the end of the 5 seconds. V equals to, you will be writing as, according to the kinematic equations, you can write it as U plus AT. Velocity after certain time interval, V equals to, you can write as U plus AT. Initially the body is given as at rest, plus with what acceleration it is moving we have calculated, and at the end of the 5 seconds they are asking. So here you can write as 8 into 5, which you can write it as 40 meter per second you can write. Now velocity you have calculated. Now kinetic energy acquired after at the end of the 5 seconds they are asking. Kinetic energy, the formula will be half mv square. Mass is given as, here it is 5 kg, and velocity we have calculated at the end of the 5 seconds, it's 40 into 40. So here you can write as 220 times 520s are 100 into 40, it will be nearly, you will be getting as 4000 joules you are getting. So this will be the correct answer. Now let us see the next question. Two spheres is given whose radii are in the ratio, is given as 1:2, are moving with their velocities, right? The velocities ratios is given as 3:4, and the densities ratios is given as 3:2. The ratio of the kinetic energies they are asking. So first radii of the two spheres is given. So here you can write as R1 by R2, which will be equal to 1/2. And their velocities ratios is given as V1 by V2, it's given as 3:4, and their densities ratios is given as D1 by D2 you can take, here it will be 3:2 is given. Now just calculate the ratio of their kinetic energies. Kinetic energies ratio, here it's nothing but kinetic energy formula, here it is half m into v square. But masses ratio it's not given, so masses you have to convert into volume into density. But here in the question it's given as two spheres is given. So mass of the sphere is nothing but, here you can write as volume into density. So here volume is nothing but, here V into here directly you can take this is 4/3 volume, in the sense here volume of the sphere you can write 4/3 pi r cube into density you can take into v square you can take. Now here kinetic energy, here among our parameters, here how it is related, first you need to identify. Here kinetic energy here which is directly proportional to, here given parameters is radius, density, and as well as velocities ratios is given. So here k is directly proportional to, you can write as r cube rho into v square you can write. Now here two values is given. Now you can write as ke1 by ke2, which will be equal to, here you can write as, this is r1 cube by r2 cube into, you can write as densities ratio, here you can write as, this is d you can take, this is also d you can take, here you can write as d1 by d2 into, here you can write as v1 square by v2 square. r1 cube by r2 cube, in the sense it becomes 1/8, and the densities ratio here it's given as 3/2 into v1 square by v2 square, means here it is 9/16 you are getting. So together 9 3s are 27, and here it will be here 8 2s are 16, 16 16 there will be getting as 256 you are getting. So the kinetic energy's ratio it is 27 by 256 you are getting. This is the correct answer. Now let us see the next question. The kinetic energy of the body is given as K is given. Right? Here if the 1/4 of its mass is removed and its velocity is double it's given, it's new kinetic energy they are asking. So initially the kinetic energy of the body is given as K equals to, the formula half mv square you can take. Now here you are removing 1/4 of its mass. After removing 1/4 of the mass, what is the kinetic energy? That means here you can take as here mass, here m dash you can take, and here its velocity you can take as v dash square you can take. 1/4 mass it is removed in this sense, remaining how much mass will be present in this sense. Here you can say here 3/4 mass will be present, and here its velocity is given as double is given. So here you can take as 2v whole square you can take. Now here you can take here this is 1/2 into 3/4 into m into here we can write it as 4v square you can take. 4 gets cancelled. Here this is here we will be getting as 3 into you can write it as half mv square you are getting. So new kinetic energy that is nothing but here 3 into here instead of half mv square here you have to take as initial kinetic energy it's given as K it's given. So here you can take as K you can take. So this is the final kinetic energy, students. So whenever the question is given a removed mass, in the sense for the remaining mass you need to calculate the kinetic energy. The next question says a particle is projected at 60 degrees to the horizontal with a kinetic energy it's given as here K is given, and your projection will be 60 degrees to the horizontal. Now here a particle you are projecting here which is making an angle 60 degrees with the horizontal it's given. This is 60 degrees is given with the horizontal, and here its initial kinetic energy at the point of projection is given as K is given. Now the kinetic energy at the highest point they are asking. Kinetic energy at the highest point here it is. So here you read already in the projectile motion. So when the body is going to be reaching the highest point here, at the highest point, initial velocity you are taking the sense you are going to be resolving as here along horizontal direction this is u cos theta, and vertical direction you are taking as u sin theta you are taking, that is u sin 60 degrees you have to take, and here also you can take as 60 degrees. And in projectile motion throughout its horizontal direction, horizontal motion, velocity remains constant you will be getting. So at the highest point what velocity it will be having, in the sense u cos theta alone will be present. U cos theta, that is nothing but u cos 60 alone will be present. This is right at the highest point in the sense here there won't be any vertical velocity, only horizontal velocity only it will be having, u cos 60 will be taking. At that point they are asking the kinetic energy. So general formula here what you can take, kinetic energy at the point of projection you can write it as half mu square you can take. When it is at the highest position, in the sense Ke dash you can take, that means here half into here m into, instead of u you can write it as u cos theta you can take. It's instead of theta you are taken as u cos 60 whole square you can take. Now here you can take outside cos 60 whole square means 1/2 whole square, that becomes 1/4 into you can write it as half into m into u square you can take. This is nothing but here you will be writing as new kinetic energy at the highest point is, this is nothing but initial kinetic energy, it is given as K is given already. Now here this is K by here you can take as 4 you can take. So this is the correct answer. Let us see the next question. When a man running on a level ground increases his speed by 4 meters per second, if his kinetic energy increases by 125%. So you are increasing its kinetic energy 125%, his initial velocity they are asking. So here increases his speed by 4 meter per second, it's given. So let us see here the first thing is here initial kinetic energy you can take as K you can take. Now finally the kinetic energy you are going to be increasing 125%. Students, here in the question by it is given in this sense, here always you have to take in any question. So to the initial kinetic energy 125% it is increasing in this sense, here you can take it as 125%. This is the way you have to represent. So to the initial by if it is given means K plus, and this is the value you have to take. Then 100K plus 125 is 225. Here together we will be writing as this is 225K by 100 you are writing. Now here you know the formula kinetic energy equal to here half mv square you are taking. Then here I am just taking as final kinetic energy by initial kinetic energy I am writing. It's nothing but half into m into, this is here you can take as v2 square by initial kinetic energy, here you can take as half mv1 square. They are not talking about the mass values here. So m by 2 you have to cancel, which is nothing but here we will be writing as v2 square by v1 square you can take. So we have calculated already final kinetic energy and initial kinetic energy. This is nothing but here you can take as 225K by 100. So by here K1 in the sense here it will come to the, this is by K you will be writing. So here which is nothing but here v2 square. So here on the level ground here initially suppose here the speed is given as here v in the sense, here let us take it as v square. And here also look at the student here his speed is increases by 4 meter per second, means here to the initial speed you have to take as 4 meter per second. Here 4 times it's going to be increasing. So here you have to take, this is the whole square you can take. Now here when you are taking this one, here you will be getting as this is 225K by here you will be writing as it K, it will come to the denominator 100K, and square you have to bring this side. So this becomes root, it becomes whole power 1 by 2, which is nothing but here we can take it as v plus 4 by v you can take. Now here k gets cancelled. 225 square root doesn't mean here we can write it as this is 15 15 is 225 by 10 10 is 100, which will be equal to v plus 4 by you can take it as v you can take. Now you have to simplify this one. Here this is 5 3 0, 5 2 0. Then here this is 3v plus 2v plus 8 will be getting, which is equal to 2v plus 8 you are taking. 3v minus 2v will be getting as v will be getting. So v equal to you will be writing as 8 meter per second you are taking. So this is the correct answer. Let us see the next question, which is given as here it is under the relation between kinetic energy and momentum. Now here the first question says if two bodies of masses 3 gram and 5 gram are moving with their linear momenta in the ratios 2:3, the ratio of their kinetic energies they are asking. So here you know the relation between kinetic energy and momentum is K equals will be taken as P square by 2m, and here you have to relate here kinetic energy, momentum and as well as masses. Masses ratio is given, momentum ratios is given, and kinetic energies ratio they are asking. So kinetic energy is directly proportional to you can take as P square by mass. Then kinetic energies ratios here if it is means Ke1 by Ke2, which you can take as P1 square by P2 square into you can take as this is M2 by M1 you can take. Then it's nothing but here Ke1 by Ke2, which will be equal to P1 square by P2 square. Its momentum's ratios is given as 2:3 is given. So here you can take as it's 4 by 9 into M2 by M1. Masses ratio is given as 3 by 5. So here we can reverse this one, it becomes 5 by 3. So here we will be getting this value will be 20 by here 27 is the correct answer. 20:27. Let us see the first next question. If the momentum of a body moving with the constant velocity is 4 times its kinetic energy. So a body is moving, it is given, and here it's moving the constant velocity is 4 times its kinetic energy. So here first you have to take momentum of the given body is given as 4 times of its kinetic energy is given. Momentum formula, you know, here mv, mass into its velocity, 4 times of, here it's given as kinetic energy, half into m into v square. Here mm gets cancelled, here vv gets cancelled. Now v equals, here will be writing as 2 times, here it becomes 1 by 2, which is nothing but will be writing as 0.5 meter per second will be getting. So here its velocity will be rating as here 0.5 meter per second is the correct answer. Now let us see the next question. If the kinetic energy of a body is increases by 300%, its momentum will be increases by. So here, you know, the relation between kinetic energy and momentum is K equals to, will be taken as P square by 2m. Now here you have to bring the relation between kinetic energy and as well as momentum. So here kinetic energy is directly proportional to, you can take as P square. Initially here if you are taken as 300% is increasing, means initial kinetic energy, let us take as here if it is you are taken as K, then final kinetic energy K2, which is nothing but here this is here you can take as K1, let us take as K you can take, and final kinetic energy, which is nothing but 300% is increasing in the sense here it's increases by its given. So here K plus here you can take as 300 K by you can take as 100 you can take, and here together we will be getting as 100 3 times, here it becomes 4K will be getting. Final kinetic energy you have calculated. Now just take here K is directly proportional to P square you are taking, and with this here I am just writing as K2 by K1, which will be equal to, you can take as P2 square by P1 square you can take. K2 already you have calculated, this is 4K by initial kinetic energy you can take as K, which will be equivalent to P2 square by P1 square. So here P2 square by you can take as P1 square, KK gets cancelled, then P2 by P1 if you are taking, it becomes the square root, here it becomes 2 will be getting. Now here its momentum will be increases by, here students we need to calculate all the way percentage changes, right? Momentum increases by, increase in momentum in the sense here you can take as P2 by P1 minus 1 into you can take as 100, which will be equal to, that means it's nothing but final minus initial 1 by, here you will be writing as initial 1 into you can take as 100 you can take. It's nothing but here you will be writing as, this is P2 minus P1 is nothing but here P2 value you can get it as 2 times of P1. So 2P1 minus P1 by, here it is P1 into 100 will be getting. So this is nothing but P1 by P1 gets cancelled, you will be writing as 100% increase will be getting. Here directly proportional to will be getting, when kinetic energy you are increasing 300% means its momentum is going to be increases by 100% you are getting. Let us see the next question. If the linear momentum is increases by 50%, it increases by 50%, its kinetic energy will be increases by, the asking. So let us first bring the relation between kinetic energy and momentum. Kinetic energy is directly proportional to P square. So let us see here initial momentum, let us take as P, and its final momentum it's increases by, so to the initial value here it's given as 50 times, here it's gone 50% is increasing. So this is the way you have to take, and here you can take as 50 by 2 times it's going. So here the final momentum you will be getting as 3 by 2 P you are getting. Now here you can take K2 by K1, which will be equal to, you can take as P2 square by you can take as P1 square. So P2 by P1 if you are taking P2 square, this is 9 by 4 P by initial momentum you can take as P you can take. This is P whole square you are getting. P it will come to the denominator, so I am just cancelling directly. So here it is 9 by 4 you are getting. So this is the kinetic energies ratios will be getting K2 by K1 which will be equal to 9 by 4. Now how much kinetic energy will be increases by? So here you can take final kinetic energy minus initial kinetic energy by initial kinetic energy into 100 you can talk. This is the kinetic and how much percentage increase in the kinetic energy. It's K2 minus K1, right? This is nothing but here you can take this. It's 9 by 4 you can take. Even you can take by taking the K1 common. So here you can write it as 9 by 4 minus 1 into 100 you can take, which is nothing but 9 minus 4. It will be 5. 5 by 4 into 100. This is here you can take as 5 by 4 into 100 you can take. 425 times here you will be writing as 125% is the right answer. Let us see the next question. If the kinetic energy of the body increases by 0.1 percentage, the percentage increase in the momentum will be. So this is the similar question, students, but here if the percentage increases or decreases value, if it is given as less than 0.5 percentage, here we need to follow the other procedure. So here the kinetic energy which is directly proportional to here K equal to you can take as P square by 2m, and here that's nothing but K is directly proportional to P square you are taking. Now here they are asking increase in the momentum they are asking. Then here momentum which is directly proportional to here we can take as root over K you can take. So here delta P by P into 100. So here for less than 0.5 percentage, here this is a procedure you have to follow. Delta P by P into 100, which you can take as this becomes here K power 1 by 2. So you can take as 1 by 2 into you can take as delta K by K into 100. So always be remember, students, here 0.1 percentage if it is given means the whole value it's given. So here you can take as 1 by 2 into you can take as 0.1 percentage. Here you have to take 2. Here it's going on 0.05 times it's going. So here 0.05 percentage is the correct answer. The next question says two bodies A and B having masses ratio is given as 3:1 possess the same kinetic energy. The ratio of their linear momentum they are asking. Here masses ratio is given in the question, m1 is to m2 which will be equal to 3:1. They will be having the same kinetic energy is given. Kinetic energy you can take as same, and here kinetic energy and which will be equal to the relation P square by 2m. It's nothing but here you can take as the linear momentum they are asking. Masses ratio is given and kinetic energy it's given as same it's given. So of course 2 is the constant value. Here now you have to bring the relation between P and M. If you are taking P square you have to take as directly proportional to M you can take, which is nothing but P is directly proportional to root M you can take. So here momentum ratios if they are talking P1 by P2 which you can take as here it is M1 by M2 you can take. So here it's nothing but here will be getting as root 3:1 will be getting. Let us see the next question. A body of mass is given here. A body of mass 5 kg. Initial at rest is given. It is acted by two mutually perpendicular forces of 6 Newton and 8 Newton simultaneously. Its kinetic energy after 10 seconds they are asking. So here a 5 kg mass it is given, and here it was experienced by two perpendicular forces. You are pushing the body here along this direction with 6 Newton's force, and here mutually perpendicularly one more force you are pushing along this direction and you are pushing along this direction, and here it's given as 8 newtons it's given. Now first let us calculate the resultant of these two forces. According to the parallelogram law of vectors, if two forces acting perpendicularly, the resultant force F equal to, here you can write it as F1 square plus F2 square, you can take under root. So this is from basically you will be getting as from parallelogram law of vectors you will be getting when two vectors are perpendicular to each other, the resultant force value. Then F is nothing but, here you can take as 6 whole square plus 8 whole square. When you are talking resultant force will be here a square root of 100, in the sense here you are getting as 10 newtons you are getting. Now let us calculate here first kinetic energy. Before calculating the kinetic energy, you just calculate velocity of velocity after 5 seconds. V equal to, you can take as u plus ct, velocity at the end of the 5 seconds. Initially the body is given as rest is given, so here you have to substitute. A is nothing but, here you can take as F by m into, you can take as T, you can take, and force value already you have calculated, this is 10, by mass it is given as 5 kg. At the end of 10 seconds they are asking, so here you can take as 5 2 times, here velocity at the end of the 10 seconds will be 20 meter per second you are getting. Now here we just calculate the kinetic energy. Kinetic energy which will be equal to half mv square, and half into mass it's given as 5 into, and this is 20 20 0 will be getting as 400, and here this is 2 times, and here you will be getting as 1000 joules you are getting. Let us see the next question. A ball of mass m at rest, at rest, it receives an impulse I1 in the direction of the north is given. Here you can see the Cartesian coordinates, dear students. Here this is a north, and this is south, and this will be the east, and this will be the west, you can take. Along east direction you are taken as Cartesian coordinate will be along I cap. So along west direction you are represented the minus I cap. North in the sense here you are taken as plus j cap, and here towards south in the sense here you are taken as minus j cap you are representing. So here you know the relation between the impulse and momentum. Impulse is nothing but, here you are taken as impulse, which is nothing but the change in momentum you are taking, change in momentum. Initially it was given as at rest is given, so but here it's receives an impulse is given as I1, in which direction, in the sense here you can take as towards north is given, so here I am just representing the j cap, which will be equal to change in momentum means final momentum minus initial momentum. Change in momentum is P final minus P initial, you can take. Initially it was given as at rest is given. P final in the sense here you can take as mass into its velocity, let us take as here it will be V1 you can take, and here it will be 0 you can take, initial momentum. Let us take this the first equation. In the second case here, after some time it is received another impulse I2 in the direction of the south. Now here in the direction of the south, in the sense here minus you have to use minus I2 j cap, which will be equal to final momentum, let us take as mv2. Initially already it will be having certain velocity, that you can take as mv1 you can take. So let us take this as equation 2. Now here you just add these two values, here 1 plus 2 when you are talking, here you can get it as it's an I1 minus I2 into j cap, which you can take as here mv1 and mv1 gets cancelled, here you will be getting as mv2 you are getting. Then v2, which you can take as this is I1 minus I2 into j cap by, here you can get it as mass you can take. So here magnitude alone you are talking, in the sense here you have to eliminate the direction, j cap you have to eliminate. So kinetic energy magnitude let us calculate here, that is half into m into, here you can take as v2 square you can take, which is nothing but half into m into, here this is I1 minus I2 whole square by, you can get it as m square, 1 mm gets cancelled. Then kinetic energy which will be equal to, here we will be writing as this is I1 minus I2 whole square by, here we will be writing as 2m you are getting. So this is the correct answer. Let us see the next question from the potential energy concept. So the first question says, here on the top of a cube of mass m1 and side A, another mass m2 is and its side B is going to be lying. If the upper block is removed, the decrease in the potential energy of the system they are asking. Here you just see the question, students. Here initially it was given as, here a mass is given m1. Here this is the mass is given as m1, it's given, and here its side is given as, here its A is given, all cube we can take. And second thing is, here it's given as, here another mass m2 you are going to be placing. This also cubical structure will be getting, and the side length is given as, here it is given as B is given. Now here you can take work done, the decrease in the potential energy of the system they are asking. When you are if the upper block has been removed, means you are doing some work. That work done is nothing but, here you can take as change in kinetic energy. So work done, which is nothing but, here you can take as work done is nothing but right, change in potential energy of the system you can take, students. So first let us calculate here initial potential energy of the system. So Ui, when I am talking here, so for any kind of uniform bodies, when you are placing, its center of gravity will be located exactly at the center. So here the center of gravity of the first mass, here it will be located at a by 2 distance you are getting. This is at a by 2 distance, and here for this mass, here it will be at a b by 2 distance will be getting. This is at b by 2 distance. Now here initial potential energy for the for the whole system when you are talking, here it will be located, right, the change in initial potential energy of the system is nothing but, here you can take as m into g into h you are taking. It's nothing but, here you can take as m1 into g into its height of center of gravity. For regular bodies and all, here you need to talk about the where the height of center of gravity will be located. So here the whole center of gravity of the system when I am talking, so here to here you have to talk. That means here this is the height of center of gravity of the system will be getting. Up to here will be getting as A, and here to here will be getting as B by 2. So this height of center of gravity for the first body when I am talking, for the first mass, here it will be A by 2 distance will be located, and second thing, here it will be for second body where it is lying in the sense m2 into g into, you can take it as, here this is A plus, here you can take it as, this is B by 2 you can talk. So initial potential energy of the system when I am talking, first you have to talk about the potential energy of the first body plus potential energy of the second body. Potential energy of the first body, this height of center of gravity will be located at A by 2 distance, and for the second body this height of center of gravity will be located at A plus B by 2 distance. Now after removing, now this one you are going to be removing, only here the first block alone will be present. First block alone will be present in the sense that the height of center of gravity, this is m1 into g into, here you can take as A by 2 you can take. So here potential energy, you know the formula, students. Here U equals to will be taken as mgh. This is the gravitational potential energy will be calling, and with that I am going to be writing all these two equations. Now here work done is nothing but, here you can take as change in potential energy. Gravitational potential energy is a conservative force. Here change in potential energy whenever you are taking, here you can take as ui minus u final you can take always. Initial potential energy minus final potential energy you can take. Here you can get it as, this is m1 into g into A by 2 plus here m1 into g final, here A by 2 plus m2 into g into this is A plus B by 2 minus m1 into g into A by 2 you can take. Here you have to cancel these two. Here work done is nothing but, here we will be writing as, this is m2 into g into, here we will be getting as a plus b by 2 you are getting. So this is the correct answer. M2 into g into a plus b by 2. This is the correct answer. Now let us see the next question. When a mass of m it is attached to a vertical spring and slowly released, the extension the spring is given as x is given. And when a mass of 2m is attached to the same spring and released suddenly, the extension the spring is there asking. Here you just look at students, here when a mass you are going to be suspending initially, so this is the spring you can take, and here this is the mass m you are taking, you are releasing slowly, right? When you are slowly released this body, in the sense here you can get it as, so after releasing this body, here weight it's going to be balanced by its restoring force. Then restoring force magnitude I am just talking, here it will be kx alone you are taking, means at equilibrium condition when you are talking, here kx which will be equal to, will be taken as mg, k is the spring constant we will be calling, x is the elongation or compression in the spring we will be calling. With this we can calculate the spring constant value, this is k equal to mg by x you are taking, means some elongation will be present. So now here in the second case, when the mass 2m when you are attaching and you are releasing suddenly. Now here let us see the next scenario. Here a mass you are going to be releasing. Suddenly when you are going to be releasing this mass, this is the 2m mass you are going to be releasing, and there will be an extension in the spring you will be getting. So here means here some extension in the spring, let us take as some right, here you can take as some x dash you can take in the spring. Now here due to this extension there is a change in potential energy of the system you will be getting, potential energy of the spring will be getting. That means here due to change in potential energy of the system, spring can be extended. So now the change in potential energy of the system, is nothing but energy stored in a spring you can take. This is nothing but u you can take. Potential energy formula, here you can write it as, this is mgh, this is here 2 into m into g, this is the mass into gravitational force I am taking, and here x dash is the new elongation in the spring you can take, 2mg into x dash is the, right, it falls by certain amount, let us take as x dash you can take. Now here you can take as potential energy stored in the spring, right? Here potential energy stored is nothing but here in a spring is half into k into x dash square you are taking, one x dash you have to cancel, then which is nothing but 2mg which will be equal to half into, here k already you have calculated, that's nothing but here you will be taken as mg by x into, you can take as x dash you can take, here this mg gets cancelled, then x dash equal to here, this is 2 times, here 2 2s will be getting as 4x will be getting. That doesn't mean here initially when slowly you are releasing, right, there will be an elongation in the spring will be x, right, suddenly when you are releasing there will be a further extension in the spring will be getting x dash, right. Here there will be change in the due to change in the potential energy of the system, here the spring is going to be extending. So means here work done is nothing but here you can take as a change in potential energy. This work done can be stored is nothing but here elastic potential energy in the spring will be calling, that is u equal to, you can write it as half kx square. This is the formula. So the final elongation in the spring it will be 4x you are getting. Let us see the next question. A rectangular block of dimensions 10 meter and 6 meter, 3 meter is lying on a horizontal surface. 6 meter, 3 meter is lying on a horizontal surface. with smallest area in contact with the surface. Now here let us take here the diagram. Here the first question, in the first thing here, it's a volume is given. Volume here it's given as here a 10 into 6 into 3 meters. Length into height into, there's a length you can take, breadth in the sense, here height it's given. And here 10 into 6 into 3 it's given. And it's a horizontal surface with the smallest area. With the smallest area in the sense, here we will be writing as 6 into 3 is the smallest area you will be getting. So here it is lying. So here it's lying in the sense, here this smallest area it's going to be lying here. This is the smallest area which is going to be lying here, and this area it's given as 18 meters square. Smallest area it's going to be contacting. Now here this area, this length, now it becomes as 10 centimeter is the 10 meter is the area. So this is here 10 meter is the height you can take, and here this is the smallest area which is going to be contacting. Now in the next case here, if the work done in arranging it with the largest area in contact with the surface is 13.86. First you have to concentrate, students. This height of center of gravity for this body in this position, here it will be located at here you can take, this is height of center of gravity will be located at, for this body it will be at 5 meters distance you can take. This is at 5 meters distance. 5 meters. Now in the second case here, we just look at, here you are taking the body and here highest area it will be in contact. Now let us take here so this is the area, highest area it's going to be contacting with the ground it's given, and here this is an area which is going to be contacting the ground it's given, and this area in the highest area in the sense, here you will be getting as 10 into 6. So 10 into 6 it carries the 60 meters square is the highest area. Then obviously the remaining it will be the the thing here, it will be the 3 meters you will be getting. So this is the height you will be getting, right? This is the height, and this will be the 60 meters square, and here we can take as 6 3s are 18 meters square is the lowest area which is in contact. Now let us see the students here. This is 3 meters height in the sense, here this height of center of gravity here at the center will be getting for this one, and this height of center of gravity for this case here will be getting as nearly at 1.5 meters distance will be getting, right? This is the second case. Now here work done by arranging this one, they are asking here the value is given, the density of the body they are asking. Now first you have to calculate here initial potential energy of the system, which will be equal to, here this is m into g into h. Height of center of gravity for the first body you are taking at 5 meters distance, and for the second body here potential energy of the system it will be mg into, here you can take as, this is at 1.5 meters, that's nothing but you can take as 3/2 you can take. Now here you can take work done is nothing but for conservative forces you can take work done to arrange initial potential energy minus final potential energy you can take, which is given as 13.86 megajoules is given 10 power 6, which will be equal to mg. When you are taking common, here you can take as 5 minus 3/2 you can take. Now here mass they have not given, you just calculate the volume into density. So here 13.86 into 10 power 6 Volume is given already, students. Here it will be in the ratio of, here are 10 meters, 10 into, here are 6 into 3 meters is given, 60 into 3, right? Here that value and all, here 180 you have to take, it is 180 meter cube into density. You can take as some rho or d you can take, into g you can take, that value also you can take as 10 you can take, students, into here this is 2 5s are 10, 10 minus 3 will be 7 by 2 you are getting. So when you are simplifying all these values here, right, density value here you will be rating as density, this is the density value you are getting as 2200 kg per meter cube you are getting, kg per meter cube, and here 1 kilogram per meter cube, which you can convert into the gram per cc. So here 1 kilogram per meter cube, in the sense this is 2200 into 10 power 3 grams, 1 kilogram equals 10 power 3 grams by 1 meter cube, in the sense 100 centimeter you are taking. So here I am just giving 1 kilogram per meter cube, which you can take as 10 power 3 gram by, and here 10 power 2 whole square, 10 power 2 centimeter whole cube you are taking. This is 10 power 3 by 10 power 6 right, centimeter cube we can take. This is together will be taken as 10 power minus 3 gram per cc. So here I am just taking 10 power minus 3 gram per cc you have to take, and here 2 zeros gets cancelled, together density you will be getting as, here d equals to, you can take as 2.2 into, here it becomes 10 power minus 1, you can write it as 2.2 gram per cc you are getting. So this is the correct answer. Let us see the next question. A simple pendulum is swinging in a vertical plane. The ratio of the potential energies it's given at the angle 30 degrees and as well as 60 degrees they are asking. Now here in this question, a simple pendulum is going to be suspended to a rigid support, and here it is going to be swinging on a vertical plane. This is a simple pendulum you can take, and it's going to be swinging on a vertical plane, like that it's going to be swinging on a vertical plane. Now the ratio of the potential energies here, suppose here the system is going to be coming over here. When it's making an angle 30 degrees and as well as 60 degrees they are asking. Now let us see here, the question says here at a particular angle they are asking. Let us see one particular angle I am just talking. Here if the simple pendulum will be at this position, this is the position of the simple pendulum you can take at a particular angle, and here which is making an angle theta you can take. So here this is the length of the pendulum you can take, here L is the length of the pendulum you can take, L is the length of the pendulum from point of suspension to center of the bob. Though it is going to be swinging, here length is not going to be changing, length remains same, we will be getting at a particular angle. And here potential energy formula, generally gravitational potential energies, U equals to, will be taken as m into g into h you are taking. Height we just calculate first. This is the vertical height which is going to be rising, h height is rising, and this is theta and this is L, in the sense cos theta value you are take as for this triangle, cos theta which will be equal to adjacent side by L by L value. Here this total length will be L and this will be h, in the sense the remaining value you can take as, this is L minus h you are taking, and here you can take as L minus h by, right, here opposite side hypotenuse will be getting as L you are taking, then cos theta which you can take as 1 minus h by L you can take, and h by L equals, you can take as 1 minus cos theta, and h you are take as, here this is L into 1 minus cos theta you can take. This is a vertical height which is going to be rising, and potential energy formula here it will be U equal to m into g into h. There you have to substitute. So U equal to m into g into h is nothing but L into, here you can take as 1 minus cos theta you can take. So this side, students, this is L minus H, this is the triangle you are taking, right? Now potential energies ratio is nothing but mgl into 1 minus cos theta you are taking. Now here you just substitute the values at a particular angles 30 degrees and as well as 60 degrees. So here so potential energy at 30 degrees by potential energy at 60 degrees, which will be equivalent to mgl into 1 minus cos 30 by, here you can get it as mgl into, here you can get it as 1 minus cos 60, you can take mgl gets cancelled, here 1 minus root 3 by 2 by, here you can get it as 1 minus 1 by 2. So together here we will be getting as, this is 2 minus root 3 by 2 into, here 1 by 2 it will come to the numerator, so it you can take as 2 by 1. So the ratios will be, here we will be getting as 2 minus root 3 by 1 will be getting. So this is the correct answer. Let us see the next question. The next question says a rubber ball falling from a height 5 meters and it's rebounds from the hard floor, and it's again here it's moving 3.5 meters. So here the question it's given, here a rubber ball is going to be falling from a height. This is falling from a height, it's given, it is hitting the floor, and this is at 5 meters distance is given, and this is at 5 meters height, and again it's going to be rebounding back, and now it's going to be rising to a height of 3.5 meters height is given. So due to the collision there will be loss in kinetic energy. Here it's going to be rising to 3.5 meters distance. The percentage loss of the energy they are asking. Here students, percentage loss of energy is nothing but potential energy loss we are going to be observing. Why? Because initial at 5 meters height, and there will be loss in potential energy, and here we will be getting a 3.5 meters distance will be getting. So you can take it as percentage change in the potential energy means PE final minus PE initial by, here you can take it as PE initial into, you can take it as 100 you can take. That's nothing but, here you can take it as mg into h2 minus mg into h1 by, here you can write as mg into h1 into 100 you can take. Mg when you are taking common, here it will get cancelled, which will be equivalent to, here you can get it as h2 minus h1 by h1 into 100 you can take. Means here here the value is given as, h2 value is given as 3.5 meters minus 5 by, here you can take as h1 value will be 5 into 100 you can take. This is nothing but, here minus 1.5 by 5 into 100 will be getting. So this is 5, 0.3 times 0.3 into 100 will be getting as 30% will be getting students. So minus represents the loss in potential energy. Here loss in potential energy, right? Percentage of loss of potential energy, which is nothing but 30% you are getting. Let us see the next question students. The potential energy function for a conservative forces is given as U equal to, here K into x plus y. Find the work done by the conservative force in moving a particle from one point to the another point they are given. So here work done for conservative forces, here which is nothing but, here you are take as change in potential energy. Change in potential energy is nothing but, here U initial minus U final you are taking, right? The potential energy function is given initially. Initial potential energy of the function is given as k of x plus y is given. Now here find the work done by conservative force in moving a particle from 1, 1 to point 2, 3. Initial potential energy you have to take students, k into, here you can take it as x initial plus y initial. It's nothing but k into x initial value will be getting as 1 plus y initial value will be getting as this is, here you can take it as x1 y1, and here this will be x2 y2 you can take. it's nothing but here we'll be getting as 1 plus 1, which you can take as 2k will be getting, and here final potential energy is nothing but here you can take as k into this is x final plus y final you can take, and x2 comma y2 let us take k into you can take this is 2 plus 3 will be getting, it's nothing but here we'll be getting as 5k you are getting. So work done by the conservative forces, work done by conservative, which is nothing but u initial minus u final. U initial value will be getting as this is 2k minus final value will be getting as 5k, which is nothing but here will be getting as minus 3k. So this is the correct answer. Let us see the next question, students. Here the question says here, a toy car of mass is given as 5 kg. It's moving up on a ramp under the influence of the force plotted against the displacement x. The maximum height attained by it is given. So here up to 11 meters distance here, right, it's moving. Here the curve is given as here it is the force versus displacement curve it's given. This is the force versus displacement curve is given. A car is moving here. Then work done is nothing but the maximum height attained by the car they are asking. So here you can take as work done is nothing but gain in potential energy of the car you can take, gain in potential energy of the car. So work done is nothing but here it's getting as area under fx curve you can take, force displacement curve, which is nothing but gain in potential energy of the system in the sense mg into car is going to be moving certain height, h maximum you can take. So area under this curve in the sense here it will be, this is an area. So area of this curve in the sense here area which will be equal to half into base into height you are taking, base into height. So it's nothing but half into base value here up to 11 meters they are asking, 11 into force value it's given as 100 newtons. This is the area under the force and displacement curve, which gives the work done will be getting. Work done by the engine of the car, which is nothing but the gain in potential energy of the system. Mass is nothing but here 5 into g into here you can take as h maximum you can take. So here are 250 times here it will be 5 times or 50 you will be getting 50 gets cancelled. So h maximum will be getting as 11 meters will be getting. So it's a vertical distance they have given in the options. So here you can take that this is 11 meters is the maximum height it is going to be moving. Now let us see the next question. The elastic potential energy of a stretched string is given by E equal to 50x square, where x is the displacement in meter and E is in joules is given, then the force constant of the spring. Elastic potential energy of the system in a spring will be E is given as 50x square. The basic formula for the elastic potential energy stored in the spring is half into k into x square you are getting. K is the spring constant, x is the elongation or compression in the spring will be taken. So now here force constant they are asking, here this x square you have to cancel. Then here we will be getting as 50 which will be equal to, it's k by 2 you are getting. Then spring constant value you can write it as 100 Newton per meter. This is the correct answer. Now the next question says two springs of spring constants is given. One is given as here it will be 1500 Newton per meter and 1300 Newton per meter respectively are stretched with the same force is given. Two spring constant values is given. They have the potential energies are in the ratios. So here potential energy stored in a spring which is nothing but, or elastic potential energy stored in a spring is half kx square it's you are taking, but they are stretching with the same force. Same force is nothing but F equal to here restoring force acting on a spring is F equal to kx, this is the magnitude. X is nothing but here you can take it as F by k you can take. So u equal to here you can take as half into k into, instead of x you can take it as F square by k square you can take. One kk gets cancelled. Why I am writing students in this form, here they have given us same force. So you must talk here in your formula. F you have to show as a constant value. So this is F square by 2k will be taken. Now you can make that this is a constant value. Now here you can relate potential energy, how it is related to the spring constant value. Now here you have to take the ratios U1 by U2, which is nothing but here you can take as K2 by K1. K2 value you will be getting as 3000 Newton per meter by 1500 Newton per meter, and here I have to cancel here, this is the 2 times, so the answer will be 2:1 is the ratio will be getting. The next question says here, when a 1 kg mass hangs attached to a spring of length is given, and here it is 50 centimeter and it is stretched by 2 centimeter. Initially you are taking one spring, you are taking a spring, you are taking, and to this one here you are hanging a 1 kg mass, you are going to be hanging. Now at the equilibrium position, when I am talking here, this is mg, and here the restoring force magnitude F equal to kx you are taking. First let us calculate the spring constant value, right, for the given condition. This is here at the equilibrium mg equal to, you can write it as kx, both the forces right, you can equate. This is the restoring force, Fr value which will be equal to kx you are taking, but minus you are getting the magnitude alone I am just talking. Then k equal to, you can take as mg by x, you can take. Mass it is given as 1 kg and g value you can take as 10 by x value it is given as here, it stretches by 2 centimeters given, you have to convert 2 into 10 power minus 2 meter, and here 2 5 times, here 5 into 10 power 2, here k value we have calculated as 500 Newton per meter. Now here the next case here, the mass is pulled down until the length of the spring becomes 60 centimeter. Initial length it's given as 50 centimeter. Now we are pulling up to 60 centimeter. So here work done, whatever the work you are doing to stretch the spring, that can be stored in the elastic potential energy. So what the elongation in the spring, in the sense elongation you are getting from 50 to 60, means here 60 minus 50 will be getting as 10 centimeter alone will be getting elongation. So whatever the work you are doing, that work done can be stored in the form of the potential energy or elastic potential energy of the spring. That's nothing but half into k into x square you can take. This is here half into k value we have calculated 500 into x is nothing but here extension in the spring you can take, that is 10 into 10 power minus 2 whole square you can take, and here you will be getting as u value, here it is 1 by 2 into 500 into, this is 10 power minus 1 whole square means 10 power minus 2 will be getting, 2 zeros gets cancelled, then u equals will be rating as 2.5 joules you are getting. So this is the correct answer. The next question says here, when the spring is stretched by 2 centimeter, it stores 100 joules of the energy. If it is stretched by further by 2 centimeter, the stored energy will be increases by. Elastic potential energy stored in the spring is u equal to half kx square, which is nothing but u is directly proportional to x square you can take, and here u2 by u1 if you are taking, here this is nothing but x2 square by, here you can take as x1 square you can take. Here you just look at students here, initially here you are stretching, here stretches by 2 centimeters, so here you can take as 2 square. You are increasing furtherly 2 centimeters, so here you can write it as initially 2 will be there, furtherly you are increasing 2, so 2 plus 2 whole square you can write. Now here it becomes 4 the 16 by 4 will be getting as 4 will be getting. This is u2 by u1. u2 by u1 is given as already 100 joules is given, which is nothing but equal to 4. Then final energy stored in the spring will be 4 into 100 will be getting as 400 joules you are getting. This will be the correct answer.